Hello, good evening, good morning, wherever you are in the world, and welcome to yet another Tag1 Team Talk. It's a real pleasure to be here today. My name is Preston, so I am a contributing editor to Tag1 Consulting and also the moderator of today's session. I want to welcome all of our viewers and our listeners, whether you're joining us by video or audio today. It's a real pleasure to welcome you to our session today. Today is going to be a really interesting session for me personally. I have long been interested in learning more about YJS, a collaborative shared editing system. And joining us today to talk about it is our three guests who are from all around the world. I'm joining you, by the way, from Mumbai, India. And first and foremost, I want to introduce our special guest, Kevin Jahns, who's a real-time collaboration systems lead at Tag1 and the creator of the library, the framework that is all the rage that we're going to be talking about today, YJS, based in Berlin.
Hello, thanks for having me.
Also joining us today, all the way from Switzerland, is Fabian Franz, Senior Technical Architect and Performance Lead at Tag1 Consulting. Hey, Fabian.
Hey, glad to be here again.
And of course, last but not least, I do want to welcome Michael Meyers, our Managing Director of Tag1 Consulting, joining us out of New York City. Hey, Mike.
Hey, everybody. Thanks for being here. Thanks for having me.
All righty. So for those of you who haven't joined us before, we have several other interesting Tag1 Team Talks that you can find on tag1consulting.com. And one of these talks actually is very relevant to today. If you want to learn a little bit more about the foundations of real-time shared editing and some of the things we're going to be talking about today, I highly encourage you to check out the very first inaugural Tag1 Team Talk available on the website about collaborative editing, and it ties directly into this. By the way, just a quick note for those of you who are joining us by audio, our listeners, also anyone who's joining us using assistive technologies, we are going to be doing some visual whiteboarding later today during this webinar. And so we do apologize for not having an oral component of that available. However, we're going to do our best to talk through things and describe everything that's going on in the video as effectively as possible. And we are going to make sure that you're able to follow along. So please be sure to check out the video if you're normally a listener to get the most out of the visual aids that we'll be presenting. And without further ado, I want to go ahead and pass the mic over to Mike, no pun intended, who's going to talk a little bit about Tag1 and why we're here today.
Awesome. Thanks, Preston. Tag1 is a consulting company. We have over 50 people around the world. We specialize in building mission-critical applications, highly available, highly scalable. If you have difficult problems to solve, we're the organization that you partner with. We're here today to talk about real-time collaboration. We think that this is an important part of the future of applications, not just web applications, but mobile and desktop applications. And we're going to have a follow-up webinar on that. Being able to collaborate and work together with your peers on a team is changing the way that we do business. You know, you spend a lot of your time in applications like Google Docs, collaborating with your team. And there are a lot of single page applications, you know, things like project management Kanban boards where, you know, awareness, even, you know, a few seconds in delay provides some friction in your workflow. And so being able to see changes in real time really facilitates working together. And so Tag1 with Kevin and Fabian are building more applications that do that. Right now, we're working on an exciting intranet for a top Fortune 50 company, which has collaborative shared editing, collaborative shared drawing and whiteboarding, and features that enable their workforce to do exactly that. And so we're interested in doing more of these applications and are excited to dig into the internals today with Kevin.
Absolutely. And, you know, for me, this is a very interesting topic myself. I've been long interested in, you know, just the very unique difficulties here and the unique challenges that come about with regards to collaborative editing. But first, I want to turn to Kevin a little bit and get a little bit of a sense from you, just from a personal side of things. What exactly got you interested in this whole idea of shared editing and real-time collaboration? I understand that you did a lot of studies in Aachen. Can you tell me more about sort of what's your background in real-time collaboration? What got you interested in it?
Yeah. So I think it all started back in 2013. I was working, I had a student worker position at the Institute for Databases and Information Systems. And I was working on the Role SDK, which was basically a clone of Google Wave. I don't know if you remember what Google Wave was, but I think it was a pretty novel approach to how collaboration could work. You had these spaces that you could design yourself, and these spaces were collaborative by default. So for example, you could add a widget, an email widget, for example, to the space and read your emails. And aside, you could have a note-taking widget, which was also collaborative. So while you read your emails, you can make notes on this widget. And for example, if you have a group account, other people could join, also read those emails and make notes too. Like, this is maybe a bad example, but everything was collaborative by default in Google Wave. And we tried to reproduce that. We had a similar product because the Wave was discontinued, unfortunately. So they tried to redevelop that. They had some pretty novel approaches there. For example, everything that you did there, these widgets, they communicated directly with each other. So just to give an example, in Google Wave, these widgets communicated with a server, and the server would coordinate everything, like sync those changes back to the other widgets and do all that stuff. But in the Role SDK, everything was peer-to-peer by default. So there was no notion of a server. So how this would work is a widget could send a message on a specific topic, and other widgets could listen to that topic. And how that message was propagated was actually, it's a bit complicated. It was part XMPP protocol, it was a multi-user chat room, and it was part cross-browser, cross-window communication via special browser communication. And later, this was easily adapted to using WebRTC. So a coworker of mine did a really cool demo, Ishtvan Koren. He put a Game Boy game, Mario, in one of these widgets and had the controls in the other widget. And he could control Mario from a different computer using the control widgets, because it was a peer-to-peer communication. So back then, everything that I wanted to do was implement a collaborative text area. And I tried, like, I had very little computer science knowledge. I didn't know about all these algorithms like CRDTs and operational transformation. Back in the days, actually, CRDT was not that, there was not a lot of research about that. So we just tried to plug in an operational transformation approach and found out, somehow it doesn't work. Why doesn't it work? Like, this got me interested in this topic. Why doesn't operational transformation work in a peer-to-peer manner? So I was about to start my bachelor thesis, and I was still hooked on this problem, and I proposed to write a framework for peer-to-peer collaboration on text. And because the main application here in the Role SDK was state sharing, I also wanted to share any arbitrary kind of state between those widgets in a peer-to-peer manner. So this is how I got started.
It's a very, sort of amazing background. And one of the things that you just mentioned that was very interesting, I think just in light of our previous conversations was the notion of being peer-to-peer, decentralized, right? Distributed systems. And I want to kind of, sort of delve into that a little bit and talk a bit about kind of the state of shared editing back in the day. One of the things I know about operational transformation, for example, is that the biggest issue with it is that there's no unique identifier that is focused on every single node in what you're editing. And as a result, you can have certain conflicts that actually arise because of that. And what I understand about CRDT is that, because there are unique identifiers, no matter where you insert, let's say, a piece of text or perform a deletion, it's always going to be tied to that location, tied to that single character as opposed to the location, as would happen in OT. And so could you talk a little bit about sort of, why is it that CRDT is so much more interesting, and how does it actually benefit things like these advantages you mentioned around peer-to-peer, offline editing, for example? and especially around things like real-time synchronization, which is, I think, a very big issue for a lot of the people watching this today.
Yeah. So the thing is, in operational transformation, it can work peer-to-peer. There have been research papers about that, but the advantage, in my opinion, about CRDTs in general is that all the operations that you define are idempotent and commutative by default. So this means no matter how often you apply the same operation, you will get the same result. Like you can apply the same operation twice, and the second time it won't do anything, for example. And commutative means it doesn't matter in which order you apply those operations. And this, because
I think it might be a good idea if you could use the whiteboard to give a little example. When I did my own research, I saw, for example, a counter example. So it was pretty good, or something like that. Maybe you have something.
Yeah, sure. I will share my screen. I will basically, we wanted to get into the whereabouts of the algorithm, and part of the interview actually was about sharing how this algorithm works. And let's just have 10 minutes and talk about the algorithm. Maybe we can even compare operational transformation and CRDTs, just to give you a quick idea of what the advantages are. I don't want to say that any of them is better, but I know that CRDTs work better for me because they are in concurrency. They are easier to understand, at least for me. All right.
Yeah. What I found kind of interesting, even though it's it's a little bit even more deeper topic, but are those recent research papers that directly compare those two approaches and kind of provide a general transformation framework where instead of working on the raw data, you are transforming it into another model. And then there's more similarities to both of those technologies. I found that idea, this approach, pretty interesting.
Yeah, definitely.
Before you begin, Kevin, I just want to point out that the whiteboarding application that you're using is actually an implementation of Why.js for collaborative whiteboarding and drawing.
Yeah. That's why I wanted to use this whiteboarding application. So during this demo, you will see the other users, the cursors, and other users can do stuff on the whiteboard too. I don't know if we are going to do this moment, but I highly recommend. Maybe I can show this to you. It's room.sh. It's a really cool application. All right. So let's just dig in. I want to give a quick example of what operational transformation is and how that works. So let's say we have two users, and these users want to do something. What you do in operational transformation is you represent these the operations that happen as a timeline. So let's say user 1, this is user 1, this is user 2, he wants to insert character A at position 0. This is going to be our notion for this operation. And he sent that operation to the other user. Now, the second user also does an operation, insert character B at position 0. And now you immediately see, hey, this is conflicting. There are two possible outcomes for this. Either we end up with the document AB or the document BA. In operational transformation, the transformation is really easy because we just compare by user ID. So the left operation here, it was created by user 1. So it gets precedence over the operation that was created by user 2. So we will end up, so we start with the document A, and we get operation B, insert this at position 0, because 2 is higher than 1, we insert B to the right of A. And at the right side, we have the document B, and we see that when the operation insert A at position 0 comes in, the client ID 1 is smaller, so we should insert A to the left of B, and all the peers end up with the same document. And I think this model of showing concurrency is really helpful. If you think about how two users work concurrently, you can model pretty complex cases like this. For example, what happens when, based on this operation, something happens here, and then maybe a third client also inserts something here. So these are just some examples to figure.
Yeah, I think it would be very good to show now the timeline part of it, because when now your third client with user ID 3 is inserting a C, but also at position 0, but it comes time-wise after these other operations have completed already, then something else happens.
Yeah, we could go over all these examples. The thing is, and there are some examples where this simple approach won't work. Though I need to mention that operational transformation can work in the peer-to-peer manner, like even with 3 clients. But you need to figure out the right algorithm for that. So it's just important to know, like, not to get lost here. But I just wanted to give you a quick overview of how that could work. I'm not sure if we should go into the details why there are some scenarios where this is complex.
Just what I meant is that if we now have this user 3 and they're inserting a C at position 0, but it happens at that time point where you're doing it, that we then end up with CAB, like we should be, because that operation comes after those other operations have completed. So there's a time component to it, not just a conflict component.
Yeah, that's actually right. You're right about that. So for example, let's say these 2 operations now come in before this user creates insert C at position 0. So this means this operation here and this operation, they got distributed to user 3. And now user 3 inserts something at position 0. Now he propagates that change to the other client, and they know that this operation, insert C at position 0, is not concurrent anymore to the other operation. So they don't need to transform it. The peers only need to figure out which operations are concurrent to each other, and then do some transformations. This is the general idea, like transformation by position. Maybe I can, oh, hello. Maybe I can give a quick example of how that works in YJS.
Yeah, with the ADTs. Will be really interesting to see this compared.
Yeah.
I agree, absolutely.
So in CRDTs, the concurrency model is a bit different. And I think that this model of having like these 3 users and the timeline, it's really, really hard to understand as soon as you get to 3 or 4 or 5 users and have these complex scenarios. It's really, like for me, it's really hard to understand those timelines. For me,
first of all, to understand the timeline, the other part that's really hard for me about operational transformation here is that also you now have to look at the now there's not just 3 users but 4, like 12 users, etc. All those operations are like coming in, and it just gets really complicated really fast.
Right. I actually, my first attempt of implementing this was based on my operational transformation. I tried to figure out all those cases, and I tried to reproduce scenarios. I had implemented a framework to show me cases where my operational transformation approach didn't work, and it would give me those examples with sometimes 7 users sending like 15 operations, and I needed to figure out, okay, where is the real problem here, and how do I really narrow the problem down to a specific thing. And then you find out, oh, okay, here's the problem. This is why this approach of operational transformation doesn't work in peer-to-peer.
And there's another problem with peer-to-peer that many people are familiar with CAP theory now, because we could have a partition, and then clients are collaborating outside of each other, and then client 3 comes in and says, hey, I'm also here, I've done some work, please take me. And all the others are like, hey, we already cooperate on this document for 5 hours, where have you been?
Yeah,
that really
Kevin, I have a quick question. I know that Google Docs, for example, is based on OT, and it caps out at a certain number of users. Is that in any way related to what you're talking about?
No, not at all. In Google Docs and most other implementations of operational transformation, you always have a central server that does the transformations. So this is a really sweet thing, because as soon as you have a central server, you have a central point where you can do the decisions of how the document should look like. And the problem becomes much easier if you have centrality. So because now you don't have to think about the case that user 1 sends an operation to user 3, because this always happens over a server. You can
and the server, and that's a very important part, it can determine a global order of all operations, which is the main thing you need, because then you have a finite state machine again, and not this mix-max of everything, every user doing anything.
Right. Yeah,
and I think that's a really great illustration, I think, of the primary benefit of CRDT, right? Is that no longer you're dealing with something that's relative. You're dealing with an absolute sense of what's changing. Just to bring it down to the level of some of our viewers who might not understand, what that means is that you no longer rely on previous things going on. You can get a sense of what is going on based on that shared history, as you both mentioned.
Right.
Yeah. Maybe we go over and make the whiteboard for the CRDT now.
Yeah, let's do that. Okay. So how I have a special notion of how I like to represent the algorithm in YJS. So this is not really this general for CRDTs. This is just specific for YJS. And I came up with the algorithm with a visual representation of the concurrency model. And it somehow goes like this. So we start with the document AB, and then we want to insert something. For example, the orange user comes in and wants to insert character C between character A and character B. And I always give each character a unique identifier. And this identifier is known as a Lamport timestamp. And it doesn't really have anything to do with actual time. It's not like Unix timestamp. No, it's just a position in the system. So something that you usually do, sorry for that, is you define the Lamport timestamp as the user ID or client ID. So in this example, the client ID will be 0, and a clock, an ever increasing clock. This is going to be 1. So user 0. Oh no, we always start at 0. We should always start at 0. That's my opinion. Computer science should always start with 0. So character C is inserted between A and B, and this is the semantic of this operation. Now we can insert another character, for example, D, between C and B. This is how it would look like: user 0 and clock increased by 1. So now we have the document A, C, D, and then B. Now you can see the linked lists, and I make an arrow always here, will represent the concurrency model and the operations that happened. And now comes to show you how concurrency would look like in this model. Would look somehow like this. Let's say the blue user comes and he wants to insert E between A and B. And you see that this operation, insert E between A and B, it is concurrent to C and D. And in order to resolve this conflict, we do the same thing as an operational transformation. We just compare by user ID or client ID. This client, the blue client, he will have client ID 1, clock is going to be 0. So since 1 is bigger than 0, we end up with the document, whoops, A, C, D, this is here, C and D, and then E, because E has a bigger client ID, and then B. So this is the same approach, the same idea as an operational transformation, but it has a different representation of how things are inserted. You can see that instead of using absolute positions, we always use IDs, because each character is identified by a unique ID. And a really cool thing about this is if something happens, not between character A and B, like somewhere else in the document, there is no concurrency at all, because don't need to be transformations. This doesn't really affect these operations.
Just to give some examples for people not familiar with how they could visualize that, it's similar to how if in the internet, instead of saying, hey, give me the server with the IP address, whatever, from Google or from Tag1, you could say, hey, give me that server that's 3 hubs away, where we have to go 3 bridges through the internet. Everyone would totally say, hey, that's difficult. Where should I know how that is, etc. The other part, how you can think about is if you're familiar with object-oriented programming, is that all of those are kind of like rich objects in your ecosystem of things. And for now, just think about them as on the same machine, kind of like processors interacting with each other and then saying, hey, I want to be here and here. And now you can see every object kind of lives on itself, and they can all see and communicate with each other kind of through these messages. And with that, you can give every object in this distributed system kind of this unique address, like the number timestamp, like Kevin said. And with that, you can really address it, and you have a unique identifier here for every character. And that's so important, because regardless of where the character moved within the last 24 hours, like a client was offline for 24 hours, and the B has moved to the very end, the client would still insert between A and B. The new F client that really wants to do this operation, because A and B can still be determined of where it should be, determining also where this order here, which before was defined by the global server, can be determined by the clients itself, because there's a logical order to it. And that makes this so powerful in that so instead of position-based, like this is here and this is here, and the position now changes from position 2 to position 20,581, you just say, hey, it's still B, and it still has, or it's still D, and it still has the identifier 0, 1, and that doesn't change. And that's so great about it. But it also brings some challenges. And yeah, for example, like large texts. Does every character needs
every character basically needs a unique ID, and this is one of the challenges, like one of the problems actually in CRDTs. It is a good concern. Is this actually usable for text editing? Think about it, a book that has like 100,000 of characters, and each character is an object, and do that in JavaScript. This seems really unperformant, right? These are like some of the challenges that you need to consider when designing a CRDT. It needs to work with hundreds of thousands of IDs, and everything is an object, and there are ways to optimize that. I basically had to work really closely with how V8 or how the JavaScript engines work in order to optimize that correctly, so that objects get represented really efficiently in memory, instead of, like, for example, instead of using objects for everything, you can define these objects in a way that JavaScript will represent this similar to a struct in C. So this is way more efficient than defining everything as a hash map, a hash table, because hash tables would be really overkill for this.
Yeah, I think you both have really well shown the fact that what we're really doing here is adding a lot of complexity, but it's also going to make things a lot more efficient. I mean, as you mentioned, Kevin, this notion that every character is an object, and that means every single one of those characters has to have a unique identifier. That leads to a lot of issues around memory and garbage collection. And one of the things that I'm curious about actually myself now, just to bring this back to really, some of the questions that our audience is going to have. One of the things that I know is a big problem for me, and I know this is a problem that all of us share, is that trying to, let's say, perform a large copy paste into a document in Google Docs, for example, it can take up to 10, 15 seconds for the synchronization, that sync process to finally complete. Or when you come back online and you get that message on Google Docs saying, oh, there's a lot of changes in this document. Can you talk through a little bit about how you can deal with those kinds of issues using this kind of this approach with CRDT?
Oh yeah, definitely. So there's a really nifty trick that I do. Oh, now I created a lot of tabs. Okay, so instead, I told you that each character is uniquely identified by some kind of clock vector like this. And most of the time, users type in a row. For example, they type A, and then they type B. This is going to be like this, and then they type C. So 2, of course. So they write words, they write characters in a row. And especially when you insert a lot of content, this is always, it will always look like this. The clock will increase always by 1 with every structure or every operations that you do. So something that you can do is instead define those operations like this. This is client 0 and clock. Sorry, I need to redo that. Okay. Okay, instead of defining this operation like this, you can also define it like this. And it has a length of 3. So it basically is ABC. It has the clock 0, but it has 3 operations. And this is what I do basically in JavaScript on text objects. Concatenate those operations so you don't need an object for every single character. You can actually have a bunch of characters together and defined as a single operation. But this makes addressing things way more complex. For example, when another user wants to insert something between B and C, for example, you need to split up this operation into 2 operations and then insert it in between. So addressing is going to be more difficult, but the memory representation and also the footprint on the database where you store your document updates is going to be much lower. And this is also the way, again, sorry.
So you're basically compressing it to a range. You're just saying, hey, this is kind of just increasing the order so I can just compress it to a range. And if someone even wants to change something within this large copied text, just then I split it up.
Right.
And something that interests me personally, are you also doing like compression after the fact or only when inserting? Like if someone was like inserting an X and then way later someone else is removing that X again, so now that phrase could be combined again. Are you doing that or?
No, unfortunately not. I can never ever combine again because in CRDTs you cannot delete characters, so you can never actually remove a character from the document tree. You can always only mark it as deleted. But again, here's something really, really cool that we do. Just an example. Let's say we mark this X as deleted. Okay, let's just say underline is deleted. Actually, better make a D here. So this means this X is marked as deleted. You can remove the content of that operation, which really makes sense when you have concatenated operations. So sometimes you have operations that have a lot of content. When you mark it as deleted, you can delete all the content. And this really pays off in production, especially when you have a large insertion and then you delete this large insertion. And an example of prose mirror, or like any structured text editor. So what we do here is we have a node, something like a paragraph node. And in this paragraph nodes, you have several text nodes, for example, A, B, C. When you delete the paragraph, you mark it as deleted. Oh, what did I do here? You mark it as deleted. You can actually mark all these structs also as deleted, and you also don't care about the order anymore. So you can actually remove these structures or these operations completely from memory. It doesn't matter, because these were children of the paragraphs that were deleted. I hope this makes sense to you. I actually don't know.
It does to me, certainly. Absolutely.
Okay, so these are just some ways of how you can optimize a CRDT implementation. Remove content, handle memory efficiently, especially consider how the JavaScript engine works. And almost all, actually all JavaScript engines like Mozilla and V8 that Chrome uses, and Safari, and now also Internet Explorer is going to use V8. All these have special optimization techniques that you can use to optimize how an object is represented in memory. If you always define an object, for example, as so roughly this is how an operation will look like. It has an ID. It has like associations to the left and right character. And what does it have too? It knows if it is deleted, and yeah, that's basically, and it has the content, right? So this is how an object is represented. And if you always define an object like that, if you never add things to that object, the compiler can actually figure out that that this is always arranged in that manner, so we can store it as a struct in memory. So instead of using a hash table, that what you would normally do, like in objects are basically hash tables, you can define this, the JavaScript compiler will optimize this as a struct, which will use very little memory in the browser or in Node.js.
Oh, okay, that makes sense, because the browser does not. So we are talking about language optimization here of how we can optimize JavaScript itself. Because if I have an object that can grow, etc., I need a hash table with an address so I can find it, can garbage collect it, etc. But if I have a fixed length data structure, then I can just allocate 10,000 of that and can use them and can later deallocate them again. So yeah, that's a really neat way of optimizing the internals here. Let me quickly go again so that I've understood this correctly, also explaining again for the readers. So when we were talking about those ranges, we were basically saying, even though we are representing this as a range, internally we still know that B, for example, still has the address of 0.1. And now you were saying that now I've inserted a paragraph and now I've deleted the content of the paragraph, and now all the information within the paragraph doesn't matter anymore. How does it deal if, for example, someone an operation comes in very, very late that wants to insert the Y between A and B, but ABC has already been deleted. How does it deal with that?
So that's a really good question. So what happens when these are marked as deleted? It doesn't matter actually. If they are marked as deleted, they are still there. Maybe their content also was deleted, but the operation itself, it is still there. And this is why concurrency still works, because you can still address a deleted character, right? You just mark it as deleted. You just say it is deleted, but it is actually still there in the internal format. To the user, you wouldn't show that character, but internally, you still need it to handle concurrency.
Okay, but you said you had some optimizations for that, so that, for example, I'm pasting the Wikipedia, probably not the whole, but some very large pages, like the largest page in Wikipedia. And now I'm not using undo, but I'm just deleting all that content again, or Mike is deleting all that content again. I paste the Wikipedia again, and Mike is deleting it again. How do you deal with that case that we don't end up with 10, 100 copies of the Wikipedia?
Right. So how do I handle that? So when you delete, there are basically two modes in JavaScript. You can have garbage collector enabled. And the garbage collector actually removes stuff. When you copy paste a Wikipedia article, you can delete content. Let me give you an example. Assuming you post this really, really, really long amount of text. So it really goes on and goes on. And this is addressed by user 0, clock 0. So it is a really huge operation, and it has, like, let's say 100,000 characters, right? When you mark this as deleted, it gets transformed to, you can delete the content, right? So it will look somehow like this, nothing, but you know it is a deleted, operation. And still, client 0, clock 0, it has a length of 100,000. And it is marked as deleted, and it doesn't have any content. So this is really cool. Now you can insert a lot of content, you delete it, and the only reminiscent, like the only thing that is still there is a single operation that is basically just 3 integers and a Boolean that say, there was once a really, really long insertion here, but now it isn't anymore. We know it is really, really long, but we don't know what it is anymore. If I then
insert between between B and C, which would be between 1 and 2.
Yeah. I mean,
then it was still, now it was inserted in this whole chunk that was deleted basically, and so it could still position it relative to the other text that is around this large pasted text.
Right. So assuming something was inserted before deletion between B and C, right? Like just that have a green user here, and he inserts X between B and C. Now another user wants to insert the X also, but now the operation is deleted. What will happen now is this operation gets split up into 2 operations. The first one is 0, 0. How much is this? 1, 2. So this is a deleted operation of a length of 2 characters. And now we have the X. And now we have a deleted operation 0, 3. Oh, actually 0, 1. So it should be 2, right? I can't count. Counting with 0 is pretty hard sometimes. Okay, so it is 2, and it has 100,000 minus 2. Just say minus 2. So it gets split up into 2 operations basically. And this is the whole trick. Now we have a bit more operations, but this splitting up it is really worth it if you do a lot of huge insertions and then delete all this content. Basically what authors of, what book authors do, or like any, a lot of people, even me, they write a huge paragraph and then they delete the huge paragraph because it wasn't good enough, or they move this paragraph to a different location. And what happens now is this paragraph was deleted and then inserted at a different position. And this is really beneficial for YJS because now the amount of text is represented way more efficiently. And even in, especially in long term, this really pays off with huge document storage improvements. Yeah. By the way,
cool.
Another advantage of how you can make this efficient is with efficient encoding techniques. So when you send this all these operations to the other peers, they really need to be represented efficiently. When you have like 100,000 of characters, like they are not merged or concatenated, they are just operations. If you send that as JSON objects, you would really blow up your memory buffer, right? Because JSON is a pretty inefficient format if you have a lot of objects. So something else that really paid off is binary encoding for that, because now you can encode each integer way more efficiently. Integers in binary are represented as 4 bits. In YJS, you can often represent an integer as 3 bits because of variable length encoding. This is what protobuf, for example, also does. Integers are, for example, the integer 1 to 127 is represented as a single byte. Other numbers need more space than that, but it can be done really efficiently. If you do that in JSON, it depends only on the length because they are transformed to a string. So a number, a simple number, could be represented in 128 bytes, not bytes, in like 5 bytes. So this is also one of the advantages of binary encoding. So I need to drink something.
No, of course, you've been going on, you both have been going on for a long time. And you know, we are coming up on time. So I do want to bring things back to, you know, we've heard a lot about the technical underpinnings of not only CRDT and how it differs from traditional OT, but also some of the ways in which you've introduced these amazing efficiencies into YJS. I'm curious, though, just to jump right back into how the audience can help out and maybe contribute some of their energy towards your project. First of all, what's sort of your, you know, I want to ask 2 questions to you, Kevin. You know, what are some of the things that you're working on next? Like, what are some of the things you want to add to YJS? And, you know, given that YJS is open source, given that we're all such open source fanatics here, how can we get involved in helping you build out YJS in the future?
All right, I'm going to first answer your second question. I would be really happy to if more people get involved. And it should be really easy by now to do that. There is a discussion board where you can post your projects, your additions to YJS. You can. YJS itself is a pretty small library. So the YJS project, it's only 10 kilobytes of JavaScript code. It's a very small module, and it only handles the concurrency part and how to encode document updates. And all the rest, for example, the communication over WebRTC, over WebSockets, the communication over, for example, the IPFS network, it's another underlying communication protocol, or XMPP. Like, there are so many additions to YJS. All these additions are separate modules. And if you are working actively with one of those projects, for example, if you have a lot of experience with that or IPFS, I would be so happy to work with you on implementing a communication module for YJS. There are also other things, for example, the editor support for example, for CodeMirror, for ACE, for ProseMirror, for Quill editor, for like there are already a lot of existing editors that are supported by YJS as separate modules, and there are still a lot of editors missing. For example, I would love to have support for Draft.js and Slate. Or it would be so interesting to have people working on additions for YJS because it is already a very modular project. It would be great to see more people getting involved and writing more editions, because this is what will drive this community. There's this discussion board that I set up just last week that we can use to collaborate, share knowledge, and I would be really happy to hear more about your experience with YJS, because all these things that we talked about in this interview and the last interview, they're already existing. They can already be used, but there's very little experience in using that. So if we have like this big, if we could share knowledge on how to implement an actual product with that, that would be really great, especially when you work on peer-to-peer technology. I would be so happy to work on more, to see YJS and more peer-to-peer technology. The other thing, what I'm working on right now is actually getting YJS version 13 released. It's been a really, really long ride on YJS version 13. Version 12 basically was so good, and it had so many additions that it is really hard to replace version 12. But now it is time to actually do that, and there's still some work to do, porting all the additions that were existing for YJS version 12 to 13. The next thing that I would be really interested in working on is peer-to-peer technology, adding YJS support, like writing a DAT module for YJS. For those of who don't know, DAT is the peer-to-peer network where users share documents with each other in a peer-to-peer manner. It's basically like BitTorrent. It has the same underlying technologies to look for other peers that are interested in the same topic, but you can make additions to a document. And there's a recent addition to the DAT network where you can have multiple users making additions to the same document. And in order to make that happen, you need some algorithm to figure out how concurrency works in that case, and YJS would be perfect for that. So this is what I'm going to be working on next.
Yeah, definitely. There's even a peer-to-peer YouTube clone-like thing. It's kind of crazy because the data is stored like nowhere, no central server at all. You always have to wait a little bit till your video loads, but then it's coming from all over the world because everyone has a little chunk of what you want to watch right now. So these peer-to-peer technologies are really, really fascinating and interesting. Also speaking for the Drupal community here, as Tag1 still being one of the Drupal experts, obviously, I'd really love to see if someone would be trying SDK for 4 version, which all of our 1 million Drupal 7 sites, my Drupal 7 sites as Drupal 7 maintainer. So the 1 million sites could just use, and all the Drupal 8 sites, all the new ones could also. So it would be really cool if there was just like a YJS plugin, someone sponsoring it, and then all of those TK into 4. I've seen how great it worked with like ProseMirror. If they all could be collaborative, that would be fantastic. And also just as a journalist saying, I've seen several open source projects in my life, developed several of my own. There's this kind of stage where you're kind of like going for the adoption. And if now many people would be using YJS, would be developing apps with it, that would be totally great in getting the feedback. It's not just code contributions, it's really just this using this, giving feedback of what works, what doesn't, what's great, what isn't. And I think this is really what pushes open source projects forwards with kind of the first step, large adoption, and the contributors come from themselves, in my experience.
Yeah.
Absolutely. Yeah, I think we can all, four of us on this webinar agree that, YJS for me is really interesting because it is, it is part of this revolution towards peer-to-peer technologies, and we're seeing a lot more of this kind of decentralization occur. It's a very important trend, and will have a lot of impact in the ways that we collaborate in the future. We are out of time, but I did want to mention a couple of things. As Kevin mentioned, we are looking for people to help contribute and offer their insights into how they're using YJS, how you're implementing YJS, what you're doing, and also some insights into other integrations. Fabian mentioned Drupal. There's also a lot of interest in other rich text editors. I want to just call out a couple of things about YJS very quickly here. If you're interested in contributing to YJS, or if you're interested in looking into YJS, please go over and visit y-js.org. Also, it's available on GitHub at github.com/YJS/YJS. Is that correct, Kevin?
That's correct.
You grab that namespace. It's a great namespace to have. Those three-letter ones on GitHub are tough to have.
That's right. I recently got that. Also, did you mention the old URL for the project? I think we also have the yjs.dev URL now. So,
okay.
So this is what we are going to use now forward. All these sweet little three-letter domains.
Yes, because adding that hyphen is so much work, right?
I just want to save your time.
Absolutely. So yjs.dev. And I think what's interesting is I just went to yjs.dev, and you actually get this really awesome live demo right on the site right there that you can take a look at. So, hey, I want to say thank you so much to Fabian and to Kevin. It's been a real pleasure chatting with you today. All the links that we've been talking about during this session are going to be available in the description, wherever this page is. Please don't forget to check out our inaugural webinar about this very topic on shared editing, where you can also hear more from Kevin and from Fabian as well. And if you're interested in learning more about a particular topic, you want to hear more about some of the things we've been talking about today, you want to learn more about CRDT, you want to learn more about some of these interesting ideas, go ahead and shoot an email over to tag1TeamTalks@tag1consulting.com. Once again, I want to say thank you to Kevin and to Fabian and to Mike today. We're going to post these talks, by the way, at tag1.com/tagteamtalks. And without further ado, thank you so much, and until next time.